Great. Hello, everyone. We are back for another episode of GIS 101. This webinar series presents a non-technical overview of topics within GIS to benefit district members and others to learn more about key GIS topics and allow them to share what they the people that they communicate with. And today we have Randall Kircher and Ibrahim Ali from the Texas Department of Transportation presenting on low distortion projections in Texas. Take it away, Randall.
Well, thank you, Emily. It's a pleasure to be here, and we hope you enjoyed the presentation. We're going to be giving you an overview of low distortion projections in Texas. This is an effort through the National Geodetic Survey to add another set of projection zones for optional use in the state of Texas. And this is a nationwide effort. There are other states involved as well. And this is kind of an overview of what we're talking about today. We'll go through some general information. We'll answer a few general questions and then take your questions at the end. Special thanks to Texas Spatial Reference Center, Texas A&M Corpus Christi, Texas Society of Professional Surveyors, TxDOT, Texas Department of Transportation, which is where I work, and Ibrahim, and also to Texas Water Development Board, which is part of their operation, the Texas Natural Resources Information System. But most of all, we had especially thank the many individuals and others that participated kind of behind the scenes or in our special stakeholders meetings to get this effort done. All right, get started. This is a national effort. It is a state plan coordinate system of 2022. It's supposed to be released at the end of 2022. I know that's going to be delayed due to some other issues. But as far as Texas goes, we are allowed 3 projection layers. We're going to be, I guess NGS will come up and do the statewide zone layer, which is probably more for GIS issues or statewide so that everything fits together in one zone, not especially I guess high accuracy. Then we have our 5 zones, which is what we currently have. We're going to maintain that in Texas. And there's an example in the middle of the screen of the central zone of what NGS is going to put together for that. And then Texas has the option of adding another layer. We can't cover the whole state with that layer, but we can do a layer of zones that cover parts of the state. And this is a close-up view of the statewide zone layer. You can note the high PPM range in the extreme western parts of the state, I guess, or northern and southern parts of the state, and that we're getting up into that 3,500 to 4,000 parts per million, error accounted for by the mapping. And this is one of the 5 zones, the central zone. That goes across the whole state from Louisiana all the way to El Paso. And as you can see, the PPM gets in that 400 range, maybe out west, but most of the state's covered in that 50 to 150 PPM range, which is good for a lot of applications. And then this is our kind of a proposal for our LDP zones, the low distortion projections. And they're smaller, there's more of them, and it allows us to keep our PPM for the most part under 20 parts per million, which is very desirable for land surveying and engineering and construction purposes. And you might wonder what's the importance of this? Well, as an agency, it's important to TxDOT because we do a lot of surveying, a lot of land surveying for right-of-way. We do quite a bit of construction and efforts such as that. There's a lot of other agencies and organizations and individuals that survey. It's important to the state for those reasons, to the citizens of the state. And one could even argue that it's a national importance. NGS is involved with it. They're national, and there's nationwide, maybe even global repercussions from changes to get our coordinate systems more accurate. And how we start with one of these is we look at the elevation, so we get a digital elevation model of Texas. And as you can see, there's a pretty wide range of elevations from going from the coast all the way to the Davis Mountains. We have a pretty pretty big range in elevations. There was also a need for recognizable boundaries for our LDPs, and it was decided by the stakeholders to use county boundaries, if at all possible, as something that's easily mapped and easily located, for the most part, on the ground. We also looked at density, population densities. We wanted to make sure we didn't split high population areas, if at all possible, such as Houston, Dallas, Fort Worth, or San Antonio, Austin. There's even some high population areas down in the Rio Grande Valley on the Mexico border. So for that reason, we started in those areas and worked our way across the remainder of the state as we built the LDPs. We also looked at road projects. It ended up, they really didn't factor, weren't a major factor in our decision-making process. We also looked at oil shale fields and such, and they're such large fields that really didn't make a major factor in our decision-making as far as the boundary lines of the LDPs. And this kind of shows the progression. You can see we started in the higher population areas in the eastern portion of the state, and then we progressed from east to west as we worked our way across the state. And that is the raster with the ppm imagery, the same as the last slide. Note that as you get out towards the west, especially if you can see Presidio in that area where you start seeing the little more color besides the green, that's where you're running into the mountainous areas and where we're not getting meeting our 20 ppm goal. And this shows our final results. The one on the left is kind of color coded so you can see the boundaries. And the one on the right here is showing the ppms. You can see we left out parts of the state as we're required by NGS. We couldn't have another coverage of a complete state coverage, I guess, with another zone. So we left out some of the less populated mountainous areas of far West Texas, Big Bend area. We did hit some small areas where there was some important work and some other surveying going on in some major, not really major, but higher population areas in the Big Bend area. So why do we need multiple map projections? Well, you know, the big problem with map projections is fitting a round Earth into a flat map. Somewhere there's going to be distortion. For example, if you look at the globe, you can see Greenland is kind of in its proper size, but once you start flattening it out to a map, if you try to keep the center of the map to be correct, something has to give, something has to distort. Something is going to be enlarged and something's going to be smaller. So if you see Greenland in this instance is much larger looking than it really is. It's larger than South America, and we know it's not even close to that size. And that's due to the type of map projection to take that round Earth and put it into a flat map. This is a couple of different kinds of projections. They're all at the same scale and they all show the same United States, but each of them have a different purpose. Some of them preserve maybe the north direction. Some of them preserve the linear direction. Maybe if you're using a road map, you want your mileage to come out correct. Some of them may preserve the area of a state, but they're all projections of the same data, just with a different projection. So some concerns with linear projection and surface adjustment factors in map projections. Well, right now, to resolve the problems with linear distortion, with our current systems, we use what we call a surface adjustment factor for smaller projects or smaller areas to try to adjust that ground to fit, or the mapping to fit the ground to fit the mapping. So we use this factor, a lot of times project specific maybe. And when you do that, you introduce another error possibility. Although you get your measurements better, it's confusing because now no longer do your projects fit together on a global scale. They all are off a little bit from each other. They don't connect because of the individual surface adjustment factors that you've used. So we run into some different problems over time, and LDPs are a good way to get around that and avoid problems like this, which I hope we never see, but I have heard stories. What causes linear distortion? Well, it's the curvature of the Earth is a horizontal distance, and you're trying to get it to a flat map. There's also, the Earth isn't perfectly round. There's different topography, and changes in that elevation change is a big factor as well. So there's really two parts to that, and one is the mapping scale, and one is the elevation scale, actually. Can we eliminate grid to ground distortion? No, not really. It changes with every point on the ground, but it's such a small change that we can minimize it. Having low distortion projections is a good way to minimize that. This is some diagrams that kind of show what we're looking at. The large zone, one zone on the left side here, it's a larger area. You're trying to fit the ground with a larger projection, and there's just more areas that you're just not going to be able to hit correctly. If you take that same projection and divide it into, say, 4 pieces or smaller, you can tailor those with the math and the LDP parameters to make it fit the ground even better. There's some of the math we used. The stakeholders in some of the first meetings we discussed, what's going to be our goal on our parts per million. And after looking at some initial results and experimentation, we kind of came up with 20 parts per million, partly because the distortion is only a foot per mile, and that's acceptable for most surveying and engineering work, and that it gives us a decent size LDP that we can work in multiple counties and catches most of the large population areas in one LDP. Are other states developing LDPs? Well, they are. There's some states that are further along and have developed LDPs already, and there are some that are working on it like we are. Oregon is one that has a quite extensive system. Of course, they're very mountainous, lots of valleys, lots of high areas. So a lot of their LDPs overlap, or they build them to overlap, such as one LDP for the valley, maybe one LDP that goes up onto the side of the mountain, trying to get their parts per million down. So they got 39 zones actually in a state the size of Oregon. Then we have Iowa and Kansas. They're a lot, I guess, more orderly in the way they were able to. They probably have a lot less relief in a lot of instances than Oregon would be. So they were able to do some different things with their LDPs. And there is the Texas ones. And as you can see, I think we ended up with 50 LDP zones. Thank you very much. Are there any questions?
Yeah, I'll go ahead with the first one. So I was curious, why would somebody use an LDP over the projections that they already have?
Well, one reason is to try to get the ground to fit your grid better, what we call it, which is fitting the mapping to the ground itself. So when we go out and measure something on the ground, that it fits really close to what our coordinates are telling us in our coordinate grid. Partially to minimize that error, and partially to make it easier for someone to calculate those things. To minimize the errors would probably be the biggest thing that we would at TxDOT, to try to make our construction fit the ground when we get there, so that we don't go on the ground and have quantities that are off. Say we need to have so much concrete in this area. Well, if our grid to ground is off too much, we may not order enough concrete or have enough concrete to get the job done. Any other questions?
Hi, I have a question. Thank you for your presentation. How will the LDP parameters be communicated or distributed to the geospatial community?
Well, we're going to distribute them as text files and PRJ files, and we're working on an LDP tool. We just finished the proof of concept. Everything is going well, and we're going to start building the LDP tool. It'll be something where you can go online and you can put in the area you're going to be working in, maybe some parameters you might want to work with, and it'll show you which projections will best serve what you're looking for in your accuracy and your precision standards. We're also going to use this tool in areas where we might have some anomalies with elevations or as such, where adjoining LDPs may work better than the actual one you fall in. So that'll take those into account as well. But that'll be available online, probably several places where we can, once we get it online, it'll be available to download and to interact with the tool.
And then can you tell us when you'll submit and get approval from NGS for the new coordinate system?
Well, we're very close to having our submittal ready. Right now, we've finished building our LDPs. We've put all the materials together, and we're going through a proofing review process right now to make sure we didn't overlook anything, that we made any, have any errors in our documentation. So the stakeholders are reviewing that now, and we're probably going to submit in the next few weeks. The deadline is actually March 31st of this year to submit, but we're ready. So we'll be submitting ahead of time, probably here 1st February timeframe.
Awesome. Well, I think that's the end of the questions we have. So thank you so much for your presentation.